Okay, guys, I'm going to be going over the review, and we're on page 3 of the packet. So if you look here, number 9, I'm just going to go through, and then remember, try to do as much as you can on my own. Like, let's say I explain it a little bit, then you can always pause the video and then watch, or like figure it on your own, and then you can try, and play the video to see if you got it correct. So number 9, it says if figure EFGH, which is right here, is rotated 279 degrees or 270 degrees counterclockwise about the origin, what would be the resulting coordinate of F? So F prime. So I really only need to look at F. So I would write it on my scrap paper, or in this case directly on the packet, at -3, 5. And that's my original, so we're trying to figure out what the F prime is going to be. So whenever you see 270, you should have two X's, and replace those X's. Replace the 270 with a 90 degrees and counterclockwise with the opposite, which is clockwise. Remember what we said, if you have X comma Y and you have a 90-degree rotation, you got to switch places. And then clockwise is, if this is pencil is 12 and you're going to go clockwise, you're going to turn to the right. So you got to change the sign of this one, whether it's negative and it becomes positive or positive and becomes negative. So if we're doing a 90 degrees clockwise rotation, we need to go in and switch these. So 5 goes here, -3 goes here. And then clockwise means I go to the right. So I'm going to change the sign of this one and let it become positive. So 5, 3 is right here. So that means it rotated 90 degrees clockwise. And that makes sense, right? So 5, 3 would make the most sense. So C is the correct answer. Look at all of these. These are all traps. Like they just switched the 5 and the 3, or they added some negatives here and there. So be super careful. Number 10. If trapezoid QRST is dilated about the origin by a scale factor of 2, what is the resulting coordinate of T prime? So again, I only have to focus on T. So just make sure that you know which one's your X and which one's your Y. So the X here is at -3, and your Y is at -2. Okay, so then T prime is going to be when you multiply each of these by 2. So -3 times +2 is -6. -2 times +2 is -4. And so that's where your new location is. It'll be coming out this way, -6, -4. So it's farther away from the origin, it got bigger. So -6, -4 is C. We don't have to worry about these other points because they didn't ask about that. They only asked about T prime, so that's kind of cool. Number 11. Again, pause and try to do as much as you can on your own. Fast forward if you think you got the answer, that kind of thing. Which transformation most likely maps figure ABCD onto A prime, B prime, C prime, D prime? Okay, so if you go from A to A prime, okay, so it doesn't look like a reflection across the y-axis because they will literally flip, and then the A would be over here, the B would be close, and then so on. So it can't be a reflection. It looks like it's definitely rotation. The question is it a 90 degree or 180? Now, if it was 180, it would end up in the opposite quadrant. So since it only went to the quadrant next over, that's a 90-degree rotation. So it can't be this one. All right. The question is it clockwise or counterclockwise? Well, notice that this is your pre-image and this is your image. How did I know? Because the pre-image doesn't have the primes. So I'm going from here, and it's not going all the way around that way. That would be like 270. So since I have to go a short distance, and there's no 270 here. So if I'm going this way, think about a clock. It's always a good idea to do 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If it's going this way, like this is going that way, okay, that's going counter. So this is a counterclockwise rotation. So C makes the most sense here, not B. The 90 made sense, but the counterclockwise is what makes more sense. Number 12. Based on the coordinates below, what transformation most likely applied to figure x, y, z to get x prime y? So how did it go from here to here, here to here, here to here? Now, if it was a reflection across the x-axis, the x would have stayed the same while the y changed. Now, the y changed, but x didn't stay the same. Okay, so it's not that. And if it doesn't work here, then it doesn't matter what's happening here. It's got to work for all of them. So let's say we reflect across the y-axis, and the y should stay the same, which it didn't, while the x changes. The x changed to opposite, but the y didn't change the same. So again, that would not reflect over the y-axis. Now, rotation. Okay, so that means if it's a 90-degree rotation, they should have switched places, and already the 5 that stayed put, the 6 stayed put. This is not a 90-degree rotation. So why does it make sense that it's a 180? Because a 180 says that they stay put, but they change signs. So 0 and 3 stayed, but then they changed signs. 0 can't change signs, so it just stayed 0, but 3 changed to -3. Here, -4 changed to +4, 8 changed to -8. So the answer is D. Number 13. Number 13, the dilation. So let's see, it went from U, V, W, X, Y, Z, U prime, V prime, all the way to the other primes. And so if you're looking at this, this is your pre-image, and then this bigger one is your image, right? So it got bigger. So since it changed size, it can't be translation, because translation would say it stayed the same and it just slid. Now the question is, the only difference, this is a dilation, but was it by a scale factor of 2 or 1/2? So this is greater than 1, but this is less than 1. Greater than 1 causes an enlargement, it gets bigger, while half causes it to get smaller. So it makes more sense that it's A. Now, if you want to know the reason for why it's 2 and not like 3 or something like that, let's take examine the one pair of coordinates. Let's say U, it's at -2, 3. And then we've got U prime, which is at -4, 6. So then what we get is, if you look at the what changed from here to here, from here to here, it multiplied by a 2, not multiplied by half. If you took half, it would have become -1 and 1.5. So it makes sense. But even if you don't know this part of it, you can tell, because this is greater than 1, this is less than 1. It had to be 2. Number 14, which transformation most likely maps C to E to, okay, so look from C to C prime, D to D prime, and then E to E prime. So C to C prime, E to E prime, D to D prime. That looks like a reflection, because it flipped over, and it looks like they're using the y-axis to flip over from here to here, here to here, or here to here, here to here. Okay, so it can't be a rotation. Well, it could possibly be, but the way it looks here, if it was a rotation, the E would have been here, and the E prime would have been here, and the C prime here. So it's not a rotation, and here's why. Let me get a patty paper. So if I were to do a rotation, okay, I would, let's say we start with this pre-image, and you have an E, a D, and then a C. And here's the origin, right? So if we do a 180 rotation, I'm going to hold my pencil down, and I'm going to turn. And yeah, it does map, and it's 180 degree, but this E ends up here, but that's not an E. That's a C prime. If this was truly a 180 rotation, there should be E prime there, and then the C ends up here, okay? But what happened was, it literally just flipped. So if I do this, like that, okay, then the C matches with the C prime, and the E matches with the E prime, okay? So it makes more sense if it's a reflection. So it's a reflection, not a translation. For sure it's not a translation. This was kind of a trap, okay, because it looks like it's a rotation, but you got to pay attention to the letters. So it's a reflection. Now, what axis was used? We used the x-axis, okay, sorry, the y-axis, okay, to flip it over, okay, and then this is where it ends up. If you were to reflect across the x-axis, it would have done something like this, and you would have had to flip it this way, and it would have stayed right here, okay? So it reflected over the y-axis, in which y it's V. Okay, number 15. Which transformation most likely maps AZ to A prime Z prime? Okay, so A to A prime, Z to Z prime. A to A prime, Z to Z prime. Looks like they both slid, right? Not a reflection. So it's translation. The question is, okay, is it 8 units right and 1 unit down, or 8 units left and 1 unit down? Now, 1 unit up. Now, one of these is a trap, because it depends on where you start. But remember, you have to start at the one that has no prime. So this is your pre-image, and this is your image. Okay, so if I go from my pre-image to my image, let's say I look at A and A prime, then I'm going right. I'm going right and then 1 unit down. Don't go left and then go up 1. That would be going in the wrong direction. So this one ends up being the trap. So like let's say you go 8 units right. Okay, 1, 2, 3, 4, 5, 6, 7, 8, and then down 1. That would make sense. Over here too. 1, 2, 3, 4, 5, 6, 7, 8, and then down 1. That makes sense with this. Now you could even say, oh, well, what if I start here? I go 8 left and up 1 unit. Doesn't this make sense? But that's not following the order. This is your pre-image and image. You never go from image to pre-image. Over here too. You start at your pre-image and then you're going to the image. Okay? Number 16. It says rectangle ABC has been rotated 90 degrees clockwise. So remember, if it helps, draw your clock. Okay, that means your clock, you have to go that way. That's clockwise, right? And reflected. Okay, so they have to do 2 things. Okay, so let's see. I'm going to try this. So there's 2 things that happen, a rotation and a reflection across the x-axis to form a rectangle. What is true about the rectangles? Okay. Oh, well, if you look at the question, this actually is, I don't even have to really worry about this that much. Okay. When you rotate something, does it change shape or size? No. When you reflect something, does it change shape or size? No. So rectangle ABCD is congruent to rectangle A. That's actually true. Like from here to here, or I'm sorry, from here to here. Okay, if you rotate it 90 degrees, not that you have to understand this, but if I rotate this 90 degrees, it'll end up going this way into this quadrant. Okay, and I should care A, B, C, D. So this is where it ends up. Okay, and then it says reflect across the x-axis. So this is your x-axis. I literally go this way, and that's where I end up. Okay, so when you do that, does it change shape or size? No, so it's congruent. Now let's see here. Rectangle ABCD is similar to that, but not congruent? No, it is, so B is out. Rectangle ABCD, this rectangle, has the same angle measures. That's true. All of their angles are the same, but different side lengths? No, all of their lengths are the same. This length is the same as that length. This length is the same as that length. So that's wrong. Okay, the same angles was right, but different side lengths is wrong. There is no relationship. That's wrong. There is a relationship. They're congruent. So A was actually the correct answer. But notice I double checked to make sure I knew why B, C, and D didn't work. Okay? All right. If you need to take a break from my voice for a minute, I completely understand. Or you can just keep pushing forward, but do come back and make sure you finish all the way up through 24. Which sequence of transformations would produce figures that are similar but not congruent? Well, if they're going to be similar, you better have a dilation involved, okay? Because if you don't have a dilation involved, it's always going to be congruent because transformations are 4, right? There's 4 of them. Rotation, reflection, translation, and then dilation, right? But dilation is the only one that changes the size, not the shape. But these 3, they always keep the same size and shape. So if you want something that's similar, dilation needs to be involved. So I see reflection here. That's going to keep it congruent. Translation, that's congruent. So that's out. A rotation, that keeps things congruent. It turns it, but it never changes the size. Reflection may flip it, but it never changes the size. So this is out as well because they're congruent. Maybe I'll put this little symbol. And then translation down units. Translation, you just slide something and it's still going to stay the same size. Dilation, ooh, there it is. That will make it similar. So after you translate something, you slide and then you either make it big or you make it small, then that's going to cause a similar shape. Rotation, hey, you turn something, same shape, same size. Translation, you slide it, same shape, same size. So since there was a dilation here and we're looking for something similar, C would be the correct answer. Number 18. Again, you can fast forward or go back as much as you need. Here's another sequence. Which sequence of transformations was most likely applied to your figure QRST? So here's my pre-image to form this, my image. Okay, so I'm going to try using a patty paper. Can we use a different one? Not that you have to, but starting here, I can see this says reflection across the x-axis. That means if you do this, what that means is I literally take this. This is my QRS, UT, and here's my x-axis, then I would have to go up over the x-axis and it would look like that. But that would not bring me here. Well, maybe it would, no, but when I translate it and down, it would not actually match up with that. So this is not a good idea. But now let's take that same pre-image, and instead of the x-axis, we're going to use the y-axis. So let's say I flip it over the y-axis like this, okay? Then it's over here, it's directly across. And then, okay, I can see that it might match up, right? So I can see it reflecting over the y-axis, definitely not the x-axis. So I'm not going to use this one. But then the y-axis works. The question is it moving 4 units up or 4 units down? So if we start here, and here's my y-axis, and I flip it over the y-axis, okay, then how do I get from here to here? Then you go up 1, 2, 3, 4, and everything matches, S, R, Q. So then you have S prime, R prime, Q prime, and then U prime, and then T prime. So it makes sense that it would go 4 units up, not down. So C is the correct answer. Number 19. Here's another sequence. Which sequence of transformations could triangle XYZ have gone through to get X prime? Okay. So once again, if it helps you, obviously you're not going to be given a patty paper during the Georgia milestones, but you can always like take your scrap paper and put it on top. But so let's say I didn't have patty paper, like this very useful patty paper. This is your pre-image, this is your image. So how would you get from here to here? I could see like if I do a 90-degree rotation clockwise, it would end up in this quadrant, okay? And then I might, and then it says, because I see, okay, all of these say 90 degrees clockwise, 90 degrees counterclockwise, 90 degrees clockwise. Okay, so there's all 90 degrees. So it could go either way. Okay, so I would say if you can, take your scrap paper and go ahead and draw and trace like your X, Y, Z, your triangle. And know this is your pre-image. Since you're rotating, you need your center of origin. So here you can put your pencil like right there. So now A says 90 degrees clockwise and then translate 4 units up and 3 units right. Okay, so let's go 90 degrees clockwise. That would give me 90 degrees here-ish. Okay, there it is. And then it says 4 units up, 1, 2, 3, 4, and then 3 units right, 1, 2, 3. That's not even on that, not even close. It's supposed to be matching up. So it's not A. Let's go back. And so now we say, okay, 90 degrees counterclockwise. So it goes to the quadrant 1. So I'm at quadrant 4. I'm going to go to quadrant 1. So let's say we end up here. And then it says, translate 3 units up and 4 units right. Okay, 1, 2, 3, 1, 2, 3, 4. Nope, not even close. So let's try the next one. Okay, 90 degrees clockwise, reflection across the y-axis. Okay. All right, so I do 90 degrees clockwise. So I end up here. And then reflect across the y-axis. That means that's going to end up back here instead of going here. So it can't be that. So then, okay, counterclockwise and then reflect across the y-axis. Okay. So let's do 90 degrees counterclockwise, which means we end up here. And then take that and reflect over the y-axis. Now that makes sense. Okay. So if I flip it, then I'm back on here. And y and x and z matches up with y prime, x prime, z prime. So this one makes sense. Okay, all right, so that's number 19. We're getting closer and closer to the end. Okay, number 20. Rectangle ABCD has been translated and then dilated, so it should get smaller or bigger. Now, yeah, it's going to get smaller because of this 1/2. So what is true? Okay, so translated 5 down. So this is my pre-image and here's my image. It went down, 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 and then it shrunk. Down, 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 shrink. Down, 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 shrink. Down, 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 shrink. Okay, so would rectangle ABCD be congruent? No, because congruent means they're same shape and size, but they're only the same shape, so this is out. They are similar, but not congruent. That's true. Well, let's see what else C says. Rectangle ABC have the same side lengths? No, they don't. As this? No. They don't have the same lengths. Like AB is longer than A prime, B prime. AD is longer than that. They should all be longer than the image. And then also the angles are actually the same. If it's 90 here, it's 90 here. If it's 90 here, the angles are always the same. That's what maintains the shape. So C is not correct. Rectangle ABC has no relationship. Yes, it does. This makes the most sense. B. Number 21. Which sequence? Here's another word, sequence of transformations. Sequence means more than one transformation, like 2 or more. Was most likely applied to get from here to here. So Q goes to Q prime, R goes to R prime, S to S prime, and so on and so forth. I can see there's a dilation, but it also looks like a rotation because it went around here. It's not a reflection because what we haven't learned about diagonal lines. So, and look at your choices. So, it looks like it's definitely a 180 rotation because it went from one quadrant to the opposite quadrant, not to its next quadrant. So it's not these. I'm going to rule those out. And then, so both of them have a rotation. Now they both dilated. Now, this is your pre-image and this is your image. Did it get bigger or smaller? It got bigger, right? So take a look at your scale factors. Okay, which one will cause it to enlarge? This would make it reduce or shrink, and this would make it enlarge, so D makes the most sense. 22, which sequence would produce two figures that are congruent? Remember, congruent is rotation, reflection, translation. Similar would be if there was a dilation involved. So translation, check. Okay, reflection, check. So it's not, oh, well, it's most likely A then. I was thinking about similar. They're congruent. How about this? A rotation and a dilation? Nope, dilation would cause similarity. So, my goodness. Here, dilation, okay, that would cause a similarity, not congruence. Dilation would cause a similarity, not congruence. So, it would have to be A. But notice I always double check to make sure I disagree with the other choices, just to make sure I'm not like accidentally circling the wrong thing. Another sequence. What would cause X, Y, Z to go onto X prime, Y prime, Z prime? Okay, so I see a dilation already. So, okay, all of these have dilation, though, so that doesn't help me. But this is my pre-image and this is my image. What happened? Did it get smaller or bigger? And went from here to here got smaller, right? So I would definitely rule these out. It's going to be one of these. So now let's see, was it a reflection across the y-axis or a reflection across the x? If it's going to reflect, okay, if I reflected this over the y-axis, you would see something on this side, but I don't. But if I reflect it over the x-axis, I see it here, and then it shrunk. So this makes the most sense, that it was flipped over the x-axis and then shrunk. Okay, now you might be like, well, after you flipped it, why is this closer than this one? And because the dilation caused it to shrink and get closer to the origin. So reflection across the x-axis, yes. Wait, which one am I looking at? This one. Reflection across the x-axis, and it shrunk, so D makes the most sense. 24, another sequence has been used to map figure 1 to 2 to 3 to 4. Which transformation was not used? Okay, so let's see, from 1 to 2, that's definitely a slide. That's a translation, so T. Let me write rotation, reflection, translation, dilation. So from here to here, it looks like it was a flip or a rotation, okay? It could be either one of those. So I'm going to say there's a translation. Okay. Was not used. Okay, well, I was kind of not reading the answers. Reflection across the x-axis. Yeah. How would 1 to 2 be a reflection across the x-axis? How would from 2 to 3? That's a reflection over the y-axis if it is. And from 3 to 4, it got larger. That's a dilation. So it was not used. Let's see here. I think A is correct. As being part of the correct answer for this. Reflection across the y-axis, I can see that because from 2 to 3, yeah, like 2 to 3, that looks like it. So we're looking for what's not used. Dilation, yeah, K equals 3 because it went from this smaller one to the bigger one. And it's 3 times bigger. So I would say from 3 to 4, that would match this, but we're looking for what wasn't used. Translation, 4 right. Remember, this plus means right with the X. Right 4 and up 5. So is there anything like that? Yeah, how about this? From here to here, we know translated. So let me look at this point and compare it with this point. Did it go right 4 and up 5? From here, 1, 2, 3, 4, 1, 2, 3, 4, 5. Sure. What if I pick this one? Then I want to see if it goes to that one. 1, 2, 3, 4, 1, 2, 3, 4, 5. So this worked too. It's this that didn't work. So hopefully that gives you some help, but again, if you were like, I still don't understand number 23 or I still don't understand number 20, make sure you work on it or go back on the video and see if you can figure it out again without my help. Alright guys, this is a really important unit, and I hope you're able to understand a little bit better. And remember that I have tutoring after school Tuesday through Wednesday of this week until 5:30. Just please make sure you have a ride. And if you want, I can be here on Saturday from 8 to 10 as long as you let me know by Thursday. Good luck, guys.